So here we are at example 7 from the 0.2 set of notes. We're asked to sketch the graph of this particular rational function. And in just looking at it, we notice that things are a little bit different than some of what we've seen before. However, the rules are pretty much still the same when we're talking about things like the vertical asymptote and the horizontal asymptote. Now, when we look at if we're just trying to find the horizontal asymptote, in the past, we said that it always followed one of those three scenarios. Well, if we look carefully, our degree on top is considered to be 1. The degree on the bottom is 2. And as a result, since the bottom is still, that degree on the bottom is still larger than the degree on the top, we still have that scenario where we end up with y is equal to 0 for our horizontal asymptote. For our VA, again, nothing really changes. You just still set this bottom not equal to 0. So then we have x squared minus 4x minus 4 is not equal to 0. And now we could just try factoring this. Unfortunately, that's not going to quite work out. So an alternative that we can do is the quadratic formula. So let's go ahead and give maybe that a shot. So we have our x values are not equal to the opposite of b. So here's b. So then really we have the opposite of negative 4, which becomes positive 4, plus or minus the square root of b squared. Well, negative 4 squared just comes out to be 16, minus 4 times our a value. In this case, it's 1. Times our c value. In this case, it's negative 4. And this should be all over 2 times our a value, which is just 1. So just 2. When we simplify things, we have 4 plus or minus the square root of 16. And then this would come out to be plus 16 all over 2. And so then even just cleaning this up a little bit more, we have 4 plus or minus the square root of 32 all over 2. And then we're just going to have to do some good and garbage with this square root of 32. We can break that up into square root of 16 being our good radical, and our bad one we'd still have 2. So in other words, I just broke up 32 into 16 times 2. Now the reason why we would do that is because we can actually take the square root of 16. So we end up then with 4 root 2 all over 2. And then just simplifying this further, we end up with x, oops, we should probably have these not equal to symbols. So x is not equal to, when you divide by 2 to the top, you'd end up with 2 plus or minus 2 root 2. Alright. So in other words then, our VAs are happening here. And let's go ahead and determine where those are at in terms of like an actual numerical value to kind of assist us at least for our graphing purposes. I'm just going to go ahead and take out my calculator. Oops. There we go. So we have 2 plus 2 root 2. Enter. And then we have 2 minus 2 square root of 2. So we end up then with these two different x values, and we can pretty much just say then that this is close to about 4.8. This is close to about -1. So when we're graphing those VAs, that's going to kind of be like what we're going to try and aim for in our graph. So we said positive almost 5 for our VA. So we are a little shy. Doesn't have to be perfect as long as it's, you know, within reason. So there's one of our VAs, and we said also negative, I just want to make sure it was negative 0.8. Oops. Yeah, so negative 0.8. So close to negative 1. Alright. Now let's go ahead and plot also our horizontal asymptote at 0. Okay. Now, since we have 3 individual spaces, because we have 2 vertical asymptotes, we're actually going to have, we're going to choose some numbers to the left of this VA right here, this negative 0.8. We're going to choose some values in between them, and then some to the right. So let's go ahead then and create a table. Here's my X, Y. Okay. So let's choose, like, for example, negative 1 is acceptable, negative 2, and negative 3. Negative 1, negative 2, negative 3. Let's also choose values like 0, 1, and 2. And then finally, some to the right of this VA. So this was 4.8. We'll go with 5, 6, and 7. One alternative I was actually kind of hoping to show you instead of like the plugging and chugging method is to actually go ahead and utilize our calculators. If we go ahead and turn it on and then go to y equals, what we're going to end up doing is actually going ahead and just typing in this particular function. So I just want to verify, but I think it's x minus 4. Oh no, it's actually x plus 4. Alright, so we're gonna go ahead and enter x plus 4. In fact, let's have a parenthesis around him first. X plus 4, close parenthesis, divided by our quadratic that's on the bottom. I'm going to go ahead and open up another parenthesis. So that's indicating then that we're actually taking the entire quadratic together instead of just like the x squared piece. So x squared, I think it was minus 4x minus 4, but let's go ahead and check. Yep. That's probably where I saw those minus 4x's. And then minus 4. Alright, so we can go ahead and graph this now, and there you can kind of see it still following those VAs. So it's kind of matching our graph so far, but if we wanted to actually find out, you know, if we wanted to actually complete like our table of values, all you'd have to do is go into second, notice it says table, and there are some of our values. Now, unfortunately, we don't see like negative 1, negative 2, negative 3. And the reason for that is because our table is actually starting at 0. And we kind of want to fix that and show some of those previous values that were to the left of like 0. So we're going to go ahead and hit second, and then table set. And we want to go ahead and set this to something else, something negative, so like maybe negative 10. And then what this simply means, this triangle table, is pretty much just like the little counters, the individual counters that things are changing by. So for example, if we go ahead and graph now, these are what I mean by those counters. So they're changing by 1 every time. An even interval of 1 unit. Now we can go ahead and hit second table, and now they're starting at negative 10. So for us, we tried the values negative 1, negative 2, negative 3. there they are. 3, a fourth, and that's going to be maybe like a 16, I want to say, or something like that, maybe. I don't know. Something around there. But then those would be our following things for our table. So you can go ahead and jot these actually down then. And then if you wanted to go ahead and see your other ones, you would just hit this down arrow. And there you can see some of those like in between and after those other vertical asymptotes. I think it's stuck in an infinite loop. Oh, I don't want that one. So I'm just going to go ahead and pull up the image so you guys can actually see that one more time. There it is. And I'll even go ahead and draw a rough sketch. So we saw something that was above here, hugged our VA. Down here it was below. And then it jumped back to above. It's actually very handy to get acclimated to your graphing calculator and how things are actually supposed to be entered. My biggest thing is remember the parentheses, okay? Otherwise, if you don't include these parentheses, it will think, your calculator will think, well, I have x plus 4 divided by x squared. It's actually going to just link this first part. So parentheses definitely matter as you're doing things in the calculator. So again, that is example 7. Oh, should probably talk about domain and range. So for our domain, we see things going out toward negative infinity. And then they are approaching this vertical asymptote of 2. This one would have been minus 2 root 2. Because in our graphing calculator, we'll get out of here. So second quit. That's where we saw that negative 0.8. 2 is when we had the 2 minus 2 root 2. Can't quite be that, so we have a parenthesis around him. Union. Then we have this same thing where it picks up right down here and continues on. So we have 2 minus 2 root 2. Goes on to 2 plus 2 root 2, which is that 4.8 whatever. So we have 2 plus 2 root 2. And then it picks up after that and goes on forever and ever. We're going to end up with 2 plus 2 root 2, comma, infinity. So again, these are going to give us the exact values for our interval notation. When we're talking about the range, it's just negative infinity, because you can keep going down up until 0 for the y value. Union, and then it just pretty much picks up. Doesn't really matter if you're over here or over here, and then moves on onwards up towards positive infinity. So that would be our range. So again, that is example 7 from the 0.2 set of notes.